Thank you. This is good to see the people who are resilient, the people who showed up this early in the morning despite having a lot of fun last night. So I am now, as Sebastian said, the head of cyber policy, the global field CISO at one of the world's largest cybersecurity companies. And what I'm going to do is, in fact, talk to you not about what my company does in all of these areas. We're active in these areas. The final one on that list is, in fact, something that I helped lead the IT sector's collaboration with government to do. What I'm actually going to do with the bulk of my time is talk to you about my lessons learned from having spent a career in the federal government doing national level programs to build cyber resilience. The four, maybe too elevated to call them guiding principles, I would probably call those rules of thumb that I tried to work by when I was running the whole of government cybersecurity programs for Presidents Bush and Obama, when after that I was the National Intelligence Manager in charge of cyber threat intelligence across the government. Those were challenging jobs, and these were the ways, the principles, the ways that I tried to think about it. And I'm going to tell you why I think each of them is important. And since we learn from failure, I'm going to tell you at least one time when I got it wrong. I know this is an audience that includes people who are both in government, who are directly supporting government, and their academic and research community partners. Full disclosure, most of what I say is really focused at the people who are trying to build resilience directly in government. But I will identify at least one area that I think is an important research challenge. So with that, let's start by level setting. I find it's always good to make sure you're using the same word to mean the same thing. I'm partial to the definition that my former colleagues at the National Institute of Standards and Technology, NIST, use. I like these verbs, and it didn't advance. There we go. Anticipate, withstand, recover from, adapt to. These are the salient things that you look to do with cyber resilience. I also like the fact that this definition is not just about working in the face of attack, working in a contested environment. The first phrase in there is, in fact, adverse conditions. My experience, having recently joined the private sector when COVID hit, was that the organizations in both public and private sector that were best able to make the transition from in-office work to remote telework were the organizations that had been building the fundamentals of cyber resilience. There are also things that are not directly in the scope of this definition of cyber resilience, and we've talked about many of these in this conference that are related to this conversation about resilience. Supply chain security. Supply chain security is a phrase that can mean two distinct things. We talk about supply chain security in the sense of adequacy, availability. Do I have a robust enough supply chain to ensure that I will have enough of the goods and services I want despite adverse conditions? At the same time, we often also talk about supply chain security to mean the integrity of supply chain. Those two things can be at tension with each other. One can be about making the ecosystem of suppliers more diverse, wider. The other can be about creating controls that can have the effect of narrowing it. Military digital resilience. This is an event supporting NATO. The reality is we could spend the rest of this conference, the rest of the year, talking about all the ways digital transformation has come to the military ecosystem, from C4ISR to how identification friend and foe works when you have autonomous vehicles, and when this marries up with classic IT networks where you have identity and access management. Let's just recognize that's important, that it is interdependent with cybersecurity, and let's put it off to the side. And what I call cognitive resilience, and I've heard other speakers talk about deepfakes, disinformation, is in fact the reality that we as nations, we as an alliance, are asymmetrically vulnerable to dis, and malinformation compared to our adversaries. It's another dimension of the resilience challenge we need to figure out how to deal with it. So those are the different meanings of resilience, but I really want to focus my talk on cyber resilience. And let me launch into those 5 principles. The first thing that I tried to manage big national programs by was to say I understood how technology, especially technology in the private sector, was evolving. The rule of thumb that I really tried to follow was this: understand those trends and be a fast follower in the programs I'm doing when I can. If I look at what industry is doing and say, I have an unmet need in government, then I'll lead because we have to. Our requirements, our resources are different. Where the alarms should start to go off, and I'm now going to throw up what I think are a good set of areas, if you find yourself doing something that appears to be working at cross purposes with the evolution of trends in the private sector. For instance, on that list I have cloud. We're in our second decade of the collective migration to the cloud. If you find yourself building a purely on-premise solution for something, recognize A, that has implications for resilience. You may be single-threaded on that. And B, it's not to say that that's the wrong answer, but I would check my logic. I would check my assumptions to make sure that doing something that appears to be that widely at variance with where technology is going is in fact the right answer. I think these are common sense. I'm not going to go through all of them. I will mention on the first one, software-defined networking, that this is the opportunity to introduce a couple of the other parts of the resilience conversation, what I call other words that start with R, and that is redundancy, and that is resourcing. The reality is that none of us are in organizations that have infinite or, frankly, adequate resources. And yet, how do we often find ourselves producing resilience? It's by having redundancy. It's by having surplus capacity. There may be occasions, such as saying, I need a dark fiber network backup. But frankly, I think software-defined networking is often a more attractive way to build resilience, to say, with something like SD-WAN, I can have 4 or 5 ways to simultaneously communicate, so if any 1, 2, or 3 of them are degraded or unavailable, I still have the others, and they're not surplus. They're all being used on an ongoing basis, so that approach, I think, is useful. The final point, and I put this one up separately in italics, is one where I think the national security communities, especially military, are leading. I said lead where you must. If I look at the unclassified prototypes, the unclassified projects that are coming out in the military space, in all domains, in terms of AI-driven autonomy, and look at where we are in most of the private sector applications, the lead, the innovation with this one is with government. This is one where I think government is actually likely to lead in the kind of capabilities that will then hopefully migrate over to operational technology resilience in civilian-led critical infrastructures. So I led with this one because this was actually something that I tried to do when I was in government, and I failed at least once. My final job in government included being responsible for trying to integrate the activities of the major cybersecurity centers of the federal government. Yet when I retired, if we were dealing with a significant intrusion, a breach, on a good day, or this was 2018, we would have a video conference to be able to collaborate. In a normal day, we'd have a conference call. And how are we doing on it? Would be a gut check. It would be basically the opinion of each person participating in the conference. Nor did we have a systematically federated, integrated way to drive action. So I retired from government thinking that this was an unmet technological need. And then I found that the private sector had largely figured out, by use of AI and by use of broad instrumentation of sensors, how to generate better situational awareness, to have a better common operating picture for its customers than we did in government, and how to drive effective integrated response better than we did in government. And I said, wow, how did I miss an evolution like that when I was trying to pay attention to IT, but while I was doing this mission of cybersecurity in government. So my challenge to you in that area is find ways to build that situational awareness. And this is a different conference, but you go to industry-focused conferences, and then you have to cut through the hype to figure out what's real and what is not. But my recommendation is it's important, try to find a trusted source of advice and counsel so you don't repeat my mistake of missing a big trend. Number two, which I also think is something that's pretty obvious, is you want to continuously or at least frequently validate what you're doing against threat. There's been a lot of talk at this conference about the characteristics of threats. As the person who ran threat analysis for the US government, as someone who earlier in his career in the intelligence community was an advanced persistent threat actor, I have to say I'm not a fan of the term because it pigeonholes the activity. While these actors can in fact be advanced, I think the thing to note is that they are flexible. They will only be as good as they have to be to get the job done in any one case. They'll start by looking at the target and say, they have unpatched vulnerabilities. I'm going to exploit one of those, or I will use malware that I can get off the dark web. They may have the capability to use a novel exploit, a 0-day, but they won't if they don't have to. While we talk about them as persistent, I think it obscures the fact that they're patient. I have seen APT activities that have taken 4 and 5 years to unfold from inception through culmination. And this is because they're not driven by profit. They don't have to make money, other than North Korea. They do cyber for a different purpose than everyone else. But that really is the defining characteristic. The third thing is, while criminal groups tend to use malicious software, malware, the nation-state actors we often associate with APTs will use the tactic of living off the land. They penetrate the target, and then they use the tools that are already resident on the system, either because they're part of the operating system or because they're there for legitimate use. There are no malicious files to look for. So when you put this variety, this flexibility of tactics together, that's why they're hard to find. That's why they're hard to counter. And you mix this capability with a doctrine that says this is no longer state-on-state activity. Our leading nation-state adversaries, who are in fact behind the APT activity we see, are targeting our civilian-owned and operated critical infrastructures, water and wastewater, telecommunications, transportation, and what I've always considered the most critical of all critical infrastructures, power generation and power transmission. If you take down power, all other critical infrastructures in civil society have a bad day as soon as the backup batteries run out. This is the challenge that we face. They have that penetration, and they have doctrines that say, as we move up the ladder from confrontation through crisis to potential conflict, even at the crisis stage, they may strike against these targets, both to impede our ability to take a military action and, frankly, to distract our national leadership's attention. If you're dealing with mass power outages and the inability to get fresh water and the inability to get your phones to work in large parts of your country, any country is going to be focused on that domestic problem as well as the international dimension. That's what makes it difficult. So how do you think about countering that? Well, for me, due diligence starts with saying strong identity and access management, because the reality is these actors, along with criminals, don't typically hack into a target. They use illicitly acquired, stolen credentials and accounts to come in. So there is a trail if you are keeping the records. We have entity and user behavioral analytic capabilities. People have talked a lot about AI in this event that we can use to find them. They're logging on at an unusual time. They're doing something unusual. If you keep the records, you can find them. I get involved in a lot of incident response, and I find victims who are using the tool they have, not the tool they should be using. The tool is not fit for purpose. They've been penetrated. They have a tool that looks for malicious files, yet it's been a living off the land actor who's not going to show up when you look at them that way. There's been a lot of talk at this conference about defense in depth. That not only applies to having multiple things in cybersecurity, something at the endpoint and something at the midpoint, so if I missed catching someone one place, I can catch them a second place. Sensors work the same way. Something that looks for patterns of user activity, something that looks like a sandbox at forensic activity, gives you two opportunities to find the action. And then for those in the crowd who are still wearing the uniform, you fight as you train. We recognize that having the plan from the executive team down through the Security Operations Center for how you're going to respond is important. You've got to do this before you get breached, and this is especially true for critical infrastructure resilience. So that's my second point. The third one is, and I know a speaker yesterday channeled Spider-Man, with great power comes great responsibility. Well, the problem is, in cybersecurity, we have the responsibility, but we typically don't have the power. We are typically held by leadership as responsible for cybersecurity, even though, yes, cybersecurity is everyone's job, but we don't have the power to do it. So in my experience, the solutions that are most likely to work are when you can come forward with a solution that actually solves multiple problems, or the gold standard is when you can recast a cybersecurity problem in terms that work for someone who is, in fact, trying to do a mission element. And here are three areas where I think that's true. And let me use Zero Trust as the example. We want to implement Zero Trust. So I'm going to go knock on the door of a mission partner and say, hi, I'm here to talk to you about how we're going to implement Zero Trust in your organization. Well, first, Zero Trust is a very off-putting label. What do you mean you guys don't trust me? We're on the same team. We're part of the same company. Zero Trust is, in fact, a concept we've been using in government for a long time. We called it need to know. We segmented our networks. The private sector had role-based access control and least privilege. That's a conversation that, because of the way you enter it, is going to be hard to do. Now you knock on the door and you say, okay, there have been evolutions in technology, there have been evolutions in how we think about this problem. Let's go to your whiteboard and let's talk about there are new ways that we can enable connectivity between the users, the devices, the compute resources, and the data, regardless of where any of those things are located. What can that possibly enable you to do tomorrow that you can't do today? Even if you can't find something that they can show you they can do, you've made the conversation about them. Cybersecurity mesh architectures. I could have put this on the technology slide because this is actually a coin termed by Gartner Research that reflects the fact that we have started to have both a consolidation of vendors and solutions in the marketplace. Instead of having 22, I ran into one company that had 107 cybersecurity tools in its environment reporting into the Security Operations Center. That is madness. I mean, we've got to have consolidation, and in fact, we are. Moore's Law means that not only are the transistors getting faster, the devices can frequently replace multiple different things, a Swiss Army knife of functionality. I put this on this slide because it turns out that if you're implementing an approach like this, it's cheaper. You save considerable amounts of money on operations and maintenance, and the latest research I saw from Gartner was that an organization could save 90% of the cost of dealing with and recovering from a breach. This is the kind of argument that the chief financial officer in an organization, as well as the cybersecurity person, will be very interested in. I said I had one research topic, deception. When we talk about cyber deception, we normally get focused on honeypots, something that is the way of last resort of finding someone who's penetrated your network or finding a malicious insider who's moving laterally. When I was in government, I funded unclassified research. I'm happy to provide anyone leads or citations to it that showed that deception technology also worked to slow an adversary. Adversaries were 75% slower if they were working in the face of deception. Their behavior was altered. They avoided the obvious target, thinking that that was probably a decoy, when in fact you forgot to protect it. There's a deterrent value. Just as having a home alarm sign means someone will frequently not target your property in preference to something else, this is something where there has not been a lot of research into it. It's a multidisciplinary problem. There's a computer science dimension. What types of deception work right under certain circumstances? There's a cognitive human factors element. The research I funded out of the government actually won some awards out of the human factors community. And there's arguably a medical dimension to it because it turns out there's a placebo effect. You don't actually have to deploy the decoy and the deception to get the benefit. There's a herd immunity bit. I don't have to have it 100% of the time, but I have to have it more than 1%. If you're in the research community in any of those areas, this is a way that I think we can collectively build resilience against the kind of nation-state threats that I described. AI. I think we've talked about AI a lot in this conference, but I don't think we've talked about AI fully in the sense that I want to. My friends at NIST talk about two forms of AI. We have discriminative AI, where you try to learn a data set well enough to be able to understand categories, to discriminate between the boundaries of categories. We've seen billions of pieces of malicious software, and we often look at trying to extract the key elements and put them in buckets so that when we see a new piece of software, we can look at it and say, malicious, non-malicious. We've been doing this one for a long time. This has been key to automation, to doing something repetitively at scale. And this has fundamentally transformed cybersecurity. We talk about the attack surface, which is usually shorthand for the size and complexity of the network, the fact that we as defenders think we have to be right 100% of the time, the attacker only has to get it right once. It's not true, but what this kind of capability from AI has done is it's given us the ability to turn that size and complexity into our advantage. We can generate enough data from sensors to know what's normal, to know what's abnormal, to know what's abnormal and just strange, abnormal from potentially and definitely malicious. And the same instrumentation that are sensors are normally controls that can take action. So when you see someone trying to attack, and they normally fail before they succeed, you block it at point of attack, you inoculate your organization globally. This has been a game changer. Other speakers have talked about their organizations see hundreds of billions to trillions of pieces of data a day. We're not going through that in manual fashion. We're using this kind of AI-driven automation to do that. That's discriminative AI. But the new kid on the block, of course, is generative AI, where you try to understand the data set well enough to be able to synthesize or generate something that would ideally belong in that. Frankly, I think the jury's still out on the value of that. Again, I talk to organizations around the world that are investing a lot of money in Gen AI, and if they're being really candid, the ones I've talked to have said, I can't actually show you a positive ROI in most cases on this. We're driven by the fear of being left out. There's something there. We're convinced there is. We don't know what it is yet. What I think is the real concern we have to think about for resilience with generative AI is other speakers have talked about we need to realize the power of AI. It comes with a huge power demand in the terms of electricity. A server that is full of the processors that do the matrix math to support large language models can use 7 times as much electricity as a server that's doing regular cloud operations. The relatively few data centers that have been built to date that are really focused on generative AI, there are economies of scale at the data center level. They're still using 5 times as much electricity. And I talk to places around the world who, frankly, when you have a demand that is growing 70% year over year for electricity, and that demand is likely to increase as we move from text-based Gen AI to multimedia, our national power grids can't keep up with the demand that we're busy trying to create. Because recognize, Gen AI demand is not happening in a vacuum. Our nations are simultaneously trying to build electric vehicle infrastructure, and we're trying to create advanced manufacturing capabilities onshore rather than in Asia. Oh, and we're doing this all against the background of climate change. I don't know how we get to success from here without making trade-offs. And the second point I underscored on there is security on Gen AI. And I'm sure everyone's heard about how you potentially risk exposing data through your queries. Query reverse engineering can help you recover it. That models can be poisoned. My colleagues at NIST said that for a model that had billions of pieces of training data, if you understood the structure of that model and the data, you could alter the output by poisoning as few as 24 training records. But those, to me, are symptoms of a broader problem we have with the security of generative AI, and that is that we don't have the equivalent of the shared security responsibility model that we have for cloud. I mean, if you want to use something in the cloud now, there's pretty broad understanding of what the data center is going to do, what you or the customer are responsible for doing. You can contract to have more and more of those services done by someone else. But this model came about over time, and it came about through repeated breaches. We don't have that in Gen AI. We have already seen failures and exploitation of fundamental disagreements about who was responsible for doing what. This is an area where, frankly, I think we need to fast track it. We don't want to take the amount of time measured in years that it took to reach an understanding of who was responsible for what in cloud. We need to get there faster in Gen AI, if we can even power it. The final area, because I know I'm running out of time, secure by design. This has been something that was the focus of the US and its national strategy last year, and it's increasingly been a focus for some other allied nations. And it's driven by the recognition that we have been going about cybersecurity in a very dysfunctional way. We have been putting the burden on the end user, individuals and corporations, to figure out what they need to do to be secure, to successfully implement it, and to keep that current on an ongoing basis. This is driven by the experience we collectively had with automotive safety, where in my lifetime, before I was a driver, but certainly while I was alive, responsibility for not dying in a car crash was solely with the motorist. We had cars that would tip over at 25 miles an hour if you turned the steering wheel too sharply. If you bought anything other than a Volvo, it didn't come with a seatbelt. You learned to drive from your dad, even if your dad was a terrible driver. A lot of things have changed to make automotive safety better. But what moved the needle of progress more than anything else was holding the manufacturers responsible for making safe cars. And that's the model that's been taken with this approach to say, look, the people in the ecosystem who can best identify risk and who can make systemic changes are the people who are making the IT products. So it is going to be incumbent on them to make IT products and services that are secure by design and that are delivered to the customer in configurations that are secure by default. Can the customer go in and change things? Yes. But it's no longer a matter of giving them a hardening guide. It's letting them turn things off and giving them the equivalent of the seatbelt chime that will nag you if you're operating in a less than secure configuration. There were 2 versions of this white paper published last year. This was the second edition. You can see the seals of the countries that signed it, countries in this room, countries in NATO. This is, in fact, something that you've already bought into at some level as a national approach to this. In the US, this was spearheaded by the Cybersecurity and Infrastructure Security Agency. The paper came out in October. They then turned to our IT sector and said, let's start to make this real. They negotiated with the IT sector. Full disclosure, I led the negotiations on the IT side on how to come up with a pledge that a number, 67 manufacturers, virtually every company that has spoken at this conference, signed at RSA with a number of principles that they committed to implementing, that they committed to showing how they were implementing. This is a tool for building resilience that you have at your disposal. We've talked a lot in closing about partnership in this conference. There's partnership between public and private sector. One of the tools we have in government that people often don't appreciate are not only do we can set regulation, we have the hard levers of law and regulation, we have the soft levers of procurement. We can say we only want to buy things that are secure by design. Models. I helped create the cybersecurity framework at NIST in 2014. We made that as an internal scorecard. If you had told me that 10 years later, people around the world would be able to say, chant with me in chorus, identify, detect, I would have thought, wait, this is never going to happen. These are the ways government can drive change. It can set standards that the private sector then develops the capability to meet. This happens domestically, this happens internationally. I've run out of time. I'm now slightly over time. I will be happy to talk to anyone either at break or you can reach out to me by email. Thank you for your time as I blitzed through this.